Welcome back, guys. In this video, we're going to do a word problem. So a skydiver dives out of a plane. The height of the skydiver t seconds after he jumps is h of t equals negative 4.9 t squared plus t plus 3900, where h of t is in meters. After he releases the parachute, his height is h of t equals negative 5t plus 3200. So it's modeled by this new function. How long after jumping does he release his parachute? Now, fairly long word problem, but to solve it, it's actually pretty simple. This is a fairly popular question you may see come up in your textbook, even on your test, so I thought I would include it. Basically, what's happening is there's two parts to this problem. The first part is before the skydiver releases the parachute. So that's modeled by this function. His height is modeled by this function. So notice that's a quadratic. And at a time of 0, he's starting at 3,900 meters. So somewhere up here. And then this is a quadratic that is opening down. The a value is negative. So it's going to look, let's say, something like this. And then the second part is after he releases the parachute. And after he releases the parachute, notice his height is modeled by a linear function with a negative slope. So let's say he releases at this point, and then after, his height is modeled by a linear function with a negative slope. So this point, this is the release point. Right? So before he releases, quadratic, this, and then after he releases, linear function. And they're asking how long after jumping does he release his parachute? So they're basically asking you to solve for this time right there. They want to know how long after jumping. Remember, t represents seconds after he jumps. How long after jumping does he release his parachute? So the way we do that is we just take both of these functions and make them equal. Basically, we're trying to figure out when does this line, when does this quadratic intersect, right? Because if we draw the full quadratic, if we draw the full line, intersection point. There's also going to be a second intersection point. You'll see when we put this in, when we solve for the intersection point, there's going to be a second one, but it's going to be negative, so we're just going to ignore that. We're just looking for that positive time. So basically, we take this function, negative 4.9 t squared plus t plus 3,900, and make it equal to negative 5t plus 3,200. Right? And we just solve for t. So bring everything over to one side. So let's bring everything over to the left side. So negative 4.9 t squared. Usually I like the a value to be positive, but in this case, I'm just going to keep it as negative. But you can take all of this, bring it to the right side, and then solve that quadratic equation. You'll get the same answer. So bringing the negative 5t over, t plus 5t, that gives us 6t. And 3,900 minus 3,200, that gives us 700. And that's going to equal 0. So now we just have this quadratic equation to solve. I wouldn't recommend trying to factor this. Throw it in to the quadratic formula. So negative b, so negative 6, plus or minus the square root of b squared. So 6 squared minus 4 times the a value of negative 4.9. times the c value of 700, all over 2 times negative 4.9. So the two t values we get is 12.58 and negative 11.36, right? But remember the negative 11.36, that represents here, right? So this ends up being negative 11.36. And then this t value here that we actually want is 12.58. Now this is not to scale, as you could tell, but generally you should see what is going on. Basically, we're finding the intersection between a quadratic and a linear function. Two intersection points, but we ignore the negative. So the answer is 12.58. So after 12.58 seconds, he releases the parachute. That's when the quadratic function changes to a linear function.